Hi there, Oliver Mo from the Targeted Operations team here at TrustedSec. In this video, we are going to go over default Active Directory configurations, as well as many other common configurations we see surrounding Active Directory during our engagements. So we are going to go over how to abuse them, and we are also going to go into how to fix them as defenders. Thank you for watching.
In this video, we will go over some of the most common attacks against an Active Directory environment and then go over countermeasures that will help protect against these attacks.
The topics we will cover is the default Active Directory settings surrounding the permissions to add computers to the domain and the default password policy. We will also go over other common configurations such as service principal names, unconstrained and constraint-based delegation, and we will also go through the do not require Kerberos pre-authentication setting. All of these are commonly abused by attackers. It is very interesting that by default, any authenticated user can add a total of 10 computers into the Active Directory domain. There are two things that makes this possible. The first thing is the MSDS machine account quota attribute. This attribute is default set to 10 and acts as a counter for each account. Every time a user adds a computer to the domain, their quota is reduced by 1. The other thing that makes this possible is the add workstations to the domain permission in the default domain controller policy. This setting is set to allow all authenticated users to perform this action. This configuration can be abused by the attackers, and I'm going to cover some of the most common attacks. One of the advantages as an attacker is to create an additional account to use in the attacks. This also works as a backup access in many cases. Also, computer accounts are often missed by SIEM solutions when they are used in attacks, making it a blind spot for monitoring. A computer account is just like a normal user account, except for the $sign in the end of the username. Computer accounts can be a member of groups, just as any other user. The default memberships for a computer account is domain computers and authenticated users. In some cases, the domain computers group has been added to other groups either by a mistake or on purpose, giving them additional access inside the environment. Attackers can then use this access to escalate privileges. A computer account also has full access to change some of its own attributes. A great example that attackers can abuse is changing the SAM account name attribute to mimic a real user to confuse defenders. Computer accounts is also often used in unconstrained delegation attacks as part of a chain of attacks. Computer accounts can add their own SPNs and add additional DNS hostnames, and is very useful in unconstrained delegation attacks. Next, we are going into the lab environment and go over some of these attacks we just discussed. Here we are logged into a Kali machine that is located inside the Active Directory lab environment. The Kali host can reach all the different hosts in that environment. So to start, we're going to map it out by using crack map exec. And here we can see we can reach a lot of different machines inside that environment. And next we're going to use an authenticated mapping by using a username and password we already know. There we go. And as you can see, we can reach 3 of the machines, but we do not get the pawned attribute from crack map exec that shows that we have local administrator access. So next we're going to try to create a computer account and see if we can use that to scan again and see if we can get more access that way. So I'm going to go into the in packets folder, examples folder, And then we're going to use Python 3, the add computer script, and the DC's IP. And then we're going to specify trusted sec int, and we're going to use the username we already know, and the password we know. Whoops. We're going to specify a specific computer name, and we're also going to specify a password. There we go. And as you can see, the machine was successfully created and added to Active Directory. So now we have a new account inside Active Directory called TARDIS $ with the password of password. So now we're going to try to use that to map the hosts and see if we get any additional access. There we go. And as you can see, they had a falsely configured web server here that allowed domain computers, for some reason, the local admin access. So now we have full control over one host, and we can escalate into that host. Fortunately for us, changing this behavior is pretty straightforward. However, there are some cases that might need special consideration. There are often personnel that works for help desk that needs to have the right to add computers to the domain, as well as accounts that perform operating system deployments. To handle this, you would use delegation to delegate the correct permissions to a group that you add those as a member of. In the upcoming demo, I will show you how to disable this behavior of allowing everybody to add computers to the domain. And I will also show you how to delegate the permissions correctly to a specific group. All right, let's move into the lab environment, where I will demo how we can prevent adding computers to the domain for all users, and also how to delegate the permissions correctly to a specific group. So here we are in Active Directory users and computers on domain controller 1 in our lab environment. And we want to change the default behavior that allows authenticated users to add computers to the domain. So first we want to create a new group that we're going to call add to domain. And we are going to go into group policy management and have a look under the default domain controller policy. And the setting we want to change is the local policy user right assignment called add workstations to domain. As you can see, it is the authenticated users group that is allowed to perform this action. So instead of changing the default domain controller policy, since it's a best practice to not do that, I'm going to create an additional group policy and link it here. I'm going to call that domain controllers adjusted settings. And then we are going to edit that group policy and navigate to the same location: policies, Windows settings, security settings, local policies, user right assignment, and go and open up the add workstations to domain. We're going to define the policy and add the group we just created. And we also need to do one additional adjustment. Since the settings are conflicting, meaning the same setting is present in two group policies, we need to make sure that the one we want to win has the lowest link order. So when there's a conflict, the one with the lowest link order will win the conflict. To verify that this works, we can do a GP update on the domain controller to reapply the group policies. And then we can switch over to our Kali machine and just try to add a computer account. So here I am on my Kali machine, and I'm doing the add computer script. from Inpacket, and I'm going to try to add the TARDIS2 computer account using a valid username and password. And as you can see, I no longer have the right to create a machine account. So that's perfect. One important thing to know is, even though we changed the default behavior, remember that users and groups such as domain administrators and the administrator account always have the right to add computers to the domain, because they are delegated the rights on the top of the domain. So we are going to pretend that we are going to delegate custom permissions, because we have a SCCM environment in place, and we want SCCM to be allowed to add computers to the locations organizational unit and any other organization unit beneath it. So we're going to create a new group again called SCCM add to domain. And then we are going to right click on the locations organizational unit, go to properties and go on the security tab and go on under advanced. And then we are going to add a new security descriptor, select principal, type in the group name. And first we are going to allow the SCCM add to domain on this object and all descendant objects to create and delete computer accounts. So let's find that. These two, create and delete computer objects. I click OK, and then I added an additional one with the same group. And this time I'm going to choose only descendant computer objects. And the things we need to add here is it needs the permission to write all properties, modify permissions. It also needs to change the password, as well as reset password. And it also needs to have the validate write DNS hostname and the validate write to service principal name. And that's the minimal amount of permissions that you need to delegate. And that's it. So if SCCM accounts are now added to this group, they're allowed to add computers to this location, and it doesn't matter how many numbers the quota is set to, because it doesn't count towards that as long as you have delegated permissions to do so. The next default setting we're going to talk about is the password policy that comes with a default Active Directory setup. It has some interesting settings, such as it remembers the 24 last passwords, and the maximum time you're allowed to have a password is 42 days, and you need to have it a minimum of 1 day. The most interesting part here is the password length. The minimum length is 7 characters, and it also needs to meet something called complexity requirements. Complexity requirements means that it needs to consist of 3 different groups that is either a lower or higher case or special character or a number. So 3 of those 4. There's also a setting called store password using reversible encryption that is set to disabled. And you also have the account lockout threshold that is real interesting, that is set to 0. 0 basically means that lockouts will never happen, meaning that you can try so many times you want to authenticate against Active Directory. And for attackers, that is really useful. So for instance, attackers can password spray all the accounts as many times as they want if the settings are set as the default. And in many cases they are. In many cases they are adjusted slightly, but some of the default settings are still there. The usernames could either be found externally using dumps or metadata from websites or whatever, or they could also be enumerated internally if there are other services in play that allows the attackers to enumerate usernames. A password spray normally uses typical passwords that fits the minimum length. Like you saw in the default password policy, the length was 7. So winter ! Would fit right in there. The same goes with winter 1 and spring ! And spring 1. They all meet the minimum complexity requirements. They contain 3 different categories of characters from the 4 different ones. When the attackers password spray, they use a lot of different tools, or there are many different tools to choose from. You have a tool called Kerberos, you have Rubius, you have a PowerShell script called the domain password spray, you have crack map exec, you can even use Metasploit, use the SMB login module, you can use Hydra, and there are many more different tools for spraying passwords. So let's head over to the lab environment and let's do a demo of how an attacker would password spray an environment. So here we are back in our lab environment, and I'm logged into the Kali attacker machine, and we are going to go through how to spray a password towards a list of usernames. But before we do that, I want to show you how to get a list of usernames if you have a valid set of credentials. So we're going to use in packets script get 80 users. So I'm going to browse into the examples directory. I'm going to use Python 3 get 80 users pi, and then I need to specify the domain and the username I want to use along with the password. And then I need to specify the domain controller IP, and I want to get all the usernames listed out. And if we run that, we can see that we get all the users. Next, we want to pipe this out to a list. So I'm going to use the cut command to cut on space, and I want to get the first part of the cut. And I'm going to pipe that to a file called usernames.txt under the root folder. And then I'm going to use nano to edit the file a little. I'm going to remove the top part of the file because that's not usernames. And then we are going to use the Metasploit framework and use the SMB login to do the spraying. So let me clear the screen, and I'm going to search for SMB login. That's the module we want to use. And then we are going to set the R hosts to the domain controller, and we are going to set the user file to the file we just created, and we are going to set the SMB domain to trusted sec. Let's see on the options. We also need to specify the password we want to try to spray. So I'm going to try spring ! So now everything should look as it should, and we just type run to start spraying. And it's done. Now we have sprayed the password spring ! on all the users in that list. And as you can see, we have 2 successes, one for Golden Dog 212 and one for Red Panda 682. So that's how you spray a password. The password policy is really easy to change, but unfortunately it impacts the organization. So this requires some planning ahead and also some communication with the users as well. There are no set of rules in terms of defining a password policy, but a recommendation would be to at least have more than 8 characters in the password, and that the password should be a passphrase. There are many different recommendations out there from NIST, from Microsoft, and many others. But a general rule of thumb is to have a complex enough password so that it's hard to crack. Also, setting a lockout policy is just as important, especially when you're dealing with attackers trying to spray passwords in your network. Next, we're going to go into the lab environment, and I'm going to demo how to change and set up the password policy to something better than the default. So here I am logged into domain controller 1, and we're about to change the password policy to something better than the default. So I want to define a password length of minimum 10 characters, and I want to lock out accounts after 4 failed attempts. I also want to change the lockout duration so that an administrator has to unlock the account manually. If you set that to 0, that will happen. I also want to reset the failed attempts counter every 8 hours, meaning that if you have 3 invalid attempts after 8 hours, it will reset to 0. Going into the group policy management, we're going to edit the default domain policy because that's where the password policy lives. As I said before, I don't like to edit the default policies, but the only exception I have is the password policy. So I'm going to edit it. I'm going to browse into Windows settings, security settings, account policies, password policy, and I'm going to change the password length to 10. Apply that, and I'm going to head into the account lockout policy, and I'm going to specify the threshold to a minimum of 4 invalid attempts before the account is locked out. It's going to suggest some values for the other twos. That's 30 minutes by default. That's fine. I'm going to change them anyway. I want to change the duration because I want that to be infinitive until the admin unlocks it. So I'm going to set it to 0. I'm also going to reset the counter after 8 hours, and that's 480 minutes. So that's how you define or change the password policy in Active Directory. Service principal names. These are used when you connect to services in Active Directory using Kerberos authentication. Essentially, it's a mapping between a service and an account. In the backend, there are many steps involved getting a valid authentication towards a service using a service principal name. I'm not going to cover the details behind this in this video, but if you're really interested, there's a lot of online resources that allows you to understand the inner workings of Kerberos and also how service principal names fit into that equation. The key point, however, is that Active Directory provides a ticket granting service ticket that is encrypted with the NTLM hash of the account used to create the service principal name. And that ticket is crackable, meaning that you can figure out the clear text password if the password is weak enough. When attackers target service principal name, they often target service accounts with registered service principal names that are members of a domain admin group or similar, or if they have access to some interesting service on the server. There are many different tools to get and extract the TGS. You have in packets, get user SPN, you have Rubios, and there's also a various amount of PowerShell scripts. The attack is referred to as Kerberoasting and was discovered first by Tim Medin. Let's head into the lab environment, and I will demo how to perform a Kerberoast attack. So here we are back in the lab environment where we're going to walk through how to do a Kerberoast attack. I'm going to use the in-package scripts for doing it. So first off, we're going to use the get user SPN script to list out all the service principal names or SPNs. It needs to have a valid authenticated account to request this information. So I'm going to use the account we used before. We also need to specify a domain controller IP and run it. And as you can see, there's only one service principal name registered in this domain. That's not true, but this is the only service principal name that is connected to a user account instead of a computer account. One thing you want to notice is the password last set as well as the last logon. In a real-world attack, you would prefer to find the password last set to something a long time ago, because then it's more probable that you will be able to crack the password. Since it's been a long time since they changed it, and it's probably we weren't that aware of complex password in the past. Also, last logon is an indication if the account is in use or not, and you probably want to take an account that is actively used. Next, we are going to add the request option as well as the output file. Output file. Like that. So now it's saved off the service principal or the TGS ticket to the file, and we can basically crack it if we want. So I'm gonna show that real quick. I have pre-staged password list with some passwords, and the account is of course made with one of those passwords. So we're going to use hashcat, and we are going to use the 13,100 hash type. That's the Kerberos one. And we're going to add the hash, of course, and then the password list. Let it go. And there we go. And now we have the password recovered. And as you can see, the password was password. So that is how you crack a password after you have Kerberoasted an account. So how do we secure service principal names, or rather the service accounts behind them? There are two important things. The first thing is the password. And in my opinion, it should be a really long and complex password. With complex, I mean just random characters and special characters without any meaning. It should also have a length of at least 25 characters. And it shouldn't really matter how long and complex the password is, because it's a password you only use or type in when you create it and when you add it as a service to a server. The other thing is privileges assigned to the service account. It's not a good idea to have like domain admin assigned to a SQL service account when it's not needed. So try to remove all the unnecessarily privileges from the account so that it's least privileged. If you don't want to hassle with password management of the service accounts, you can always consider using managed service accounts, or if you have a service account that is implemented on several servers, you could use something called group managed service accounts instead. This will make sure that the password auto-rotates and is completely random at any time. So let's head over to our lab environment, where I will demo how we can secure service principal names. So here we are back at the domain controller in the lab, and I'm going to show you how to secure service principal names, or the service accounts that are linked to them. So first off, I'm going to show you just a PowerShell script that you can use to list out all the service principal names that you can find on social technet, Microsoft.com. I'm just going to run this, and it will list out all the different SPNs. And as you can see, there's a lot of different ones that are related to system related stuff that are always there by default. The one we are interested in is the SQL service that we attacked in the previous demo, and it's located under the user's container. So let's head over to to the users container and have a look at the account. So here we have the SQL service account. And if we first start by looking at the member of, we can see the membership. And oh my god, we can see that it's member of domain admins. So that needs to be changed. So in a production environment, you would typically log into the server that uses this account and just change the needed permissions locally on the server. Doing it like this is a shortcut, so you don't have to add the needed permissions on the different servers. But the effect of it is that the SQL service account now has full access to everything in the domain. So we don't want that. So start by removing this, apply OK. Next up was the password. The password was set to password and it was easy to crack. So we're going to just change that to something really random. So I'm just going to Notepad. I'm going to type something random. That password should be hard enough to crack. So copy that and go into the SQL service account and choose reset password. Paste that in, hit OK. And then we need to update this on the server side as well. So I'm going to switch over to the web server. And then we are going to go into services and find the SQL service. And we are going to, under the logon tab, change the password to the one we just updated to. Apply OK, and we're done. I also mentioned managed service accounts. So I'm going to walk you through how to set that up as well. To do that, we first need to go back to the domain controller and run some PowerShell commands there. So here we are at the domain controller again, and I'm going to open up PowerShell. And we are going to create something called an AD service account. So new AD service account. We are going to name that for MSA SQL. And I'm going to set enabled to true. And I want to restrict this to a single computer. Next, I also need to add AD computer service account. I need to specify an identity. In this case, it's web1. And the service account is MSA SQL that we created before. That's it. Next, we need to go back to the web server and do some configuration there as well. So here we are back at the web server. First thing, I need to add the PowerShell commandlets for Active Directory. So I'm going to do that through Server Manager. I'm going to go into Manage, add roles and features, click Next, go into Role and click Next, choose the correct server, skip server roles. In the features, I want to go down to Remote Server Administration Tools, expand that, choose Role, and under Role find ADDS and checkmark the Active Directory module for Windows PowerShell. Click Next, click Install, and then you need to just wait until it's done. And there we have it, it's installed. So let's open up the PowerShell with the Active Directory components. There we go. And then we are going to do install AD service account. We are going to specify the identity of MSA SQL. Now it's installed. Next we need to go into the service itself. And then we need to change the logon properties here. And we need to specify trusted sec, that's our domain, and the service account name with $. And then we can just remove this. and click apply. And we're done. So every now and then Active Directory will rotate the password, and it should never affect the service. There are however, some services that don't support managed service account, so that's something you need to verify and test before you roll this out on every single service you have in your environment. ASP Preauthentication, that's something that is controlled by setting a checkmark in the user account options. The setting is named Do Not Require Kerberos Preauthentication. And what it does is that it disables the pre-authentication phase during a normal authentication, where you take a timestamp and you encrypt that with the password hash of the user and presents that to the domain controller to verify. You skip that phase, and since you do that, any attacker with a valid set of credentials can request a TGT for the account that has this checkmark turned on. And the tools that you can run as an attacker is able to extract AS rep hash that can be cracked using Hashcat or other similar tools. The most known tools for doing AS Preauthentication is either Rubios or Impacket's get np user pi script. Both of them do an equally good job. Depending on the scenario as an attacker, one might be better to use than the other. And now let's head into our lab environment, and I can demo how to do AS Preauthentication. So here we are in the lab environment again, and I'm logged into the Kali attacker machine, and we're about to do an AS Preauthentication attack using Impacket's get np users pi script. So I'm going to start by browsing into the correct directory. This is where I have all the scripts from Impacket. Then I'm going to do the Python 3 get np user pi, and then we need to specify some credentials. So we're going to use the ones we already know of. And I also need to specify a domain controller IP address. If I run this now, it will list out all the accounts in the domain that has the checkmark turned on for disable Kerberos Preauthentication. Next, we would like to do a request based on this, and we want to output the results to a file. So I want to pipe that to root, AS rep hash, and hit enter. So now we have a file called AS rep hash with the correct format. So next we would like to do Hashcat to crack the hashes. So we're going to do that. And the hash type for AS rep is 18,200. Specifying a word list attack. I have to input the hash and a word list and start. So there we have it. Password cracked. Password. So that's how you do a AS Preauthentication attack. The do not require Kerberos Preauthentication is pretty easy to fix. It's all a matter of just removing the checkmark from the account. The challenge, however, is to find out which accounts has this enabled. So I normally use the following PowerShell one-liner to list them out. This is using a native AD user commandlet with the filter of star, meaning every account. And then I include the properties does not require pre-auth. That's the attribute you're looking for. Then I'm piping that, and then I'm listing out all the objects that does not require pre-auth to true. Then I'm piping that to a format list where I only output the user principal name, SAM account name, distinguished name, enabled, and does not require pre-auth. that's all there is to it. Unconstrained and constrained delegation. This is used by Active Directory to configure server or services to allow access to other services on behalf of the user. A good example is a front-end web server that needs to update a backend system on behalf of a user. In that scenario, you can configure either unconstrained or constrained delegation. Unconstrained delegation is a little more powerful or has more permissions than the constrained delegation. Unconstrained delegation is allowed to impersonate any account towards any service in the domain. Thereby, it's pretty dangerous to configure this to a system. Constrained delegation, on the other hand, only impersonates towards specified services, meaning that you can narrow down what sort of service the server is allowed to impersonate towards. Meaning that you can specify that our front-end web server is only allowed to impersonate users towards a specific backend system on a specific service. To configure unconstrained delegation, one option to configure this is to go into Active Directory Users and Computers, open up the Properties dialog for a computer account, and go to the Delegation tab, and then checkmark the Trust this computer for delegation to any service. When this is checked, the computer account is allowed to delegate any user towards any service in the domain. To configure constrained delegation, on the other hand, you go into the same location as you did for unconstrained delegation. The only difference is that you checkmark the Trust this computer for delegation to specified services only, and you choose either to use Kerberos only or any authentication protocol. You're also able to specify the service type and as well as the computer that you want to be allowed to delegate to. So how do we abuse unconstrained delegation? Well, first you need to get full control of a system that has unconstrained delegation enabled. When I say full control, I mean administrator access to the system. After you have full control, you need to get an admin, a domain controller, or any other account you want to target to connect back to the system you now control. You can do that with, for instance, a shortcut with a UNC path placed on a file share, spool sample, or any other technique. The cool thing now, since the system has unconstrained delegation enabled, is that it stores the incoming TGTs in memory, and you can extract those. After you have extracted the tickets, you can then use that ticket you extracted to impersonate the account that was connected. So, for instance, if a domain admin connected, you can then use his ticket to be a domain admin. So how do we abuse constrained delegation? It's pretty much the same process. You need to get control of the system with constrained delegation first, and then you need to figure out the systems that the system you compromised has delegation rights to. One way of doing that is looking at the MSD as allowed to delegate to, because that will show exactly what sort of services and servers you are able to delegate to. Next, you need to obtain a ticket granting ticket for the system you compromised, the system with constrained delegation. And then you need to request a ticket granting service ticket using the ticket granting ticket that you obtained. And you need to enable the S4U to be able to impersonate any other account. And then you need to load that ticket, and you should be able to access the service using the impersonated account. Now let's head over to the lab environment, where I will demo how to do an unconstrained delegation attack and escalate to a domain administrator. So here we are on the server web1, logged in as the user Odvermo. And Odvermo was able to take control over this server by, let's say, he took advantage of a known exploit or something like that. Either way, he has full control over web1, and this system has unconstrained delegation enabled, and that is what we're going to abuse next to escalate to a domain administrator. So first, I have already downloaded a tool for this that's called Remediation, and we are going to use this to just look for incoming TGTs, or if somebody connects, it stores the TGT in memory, since this is a system that is enabled for unconstrained delegation. So I'm going to set the interval to 5, and I also want to filter, typo. I also want to filter user IT admin, and I want to make sure no wrap, so the output looks prettier. Okay, so now Remediation is running. It's looking for incoming connections and looking for TGTs in memory, and it will show it on the screen if they appear. So to speed up this process, we are going to pretend that we are an IT admin that is logged into the domain, and we manage computers and such. So we had an issue with the Web1 server, and we want to manage that. So we right click and manage, so we connect to it. And in the backend now, we should have gotten the ticket we need. And there we have it. So let's just grab this ticket, exit out of Remediation, and then we can try to list out the domain controller's $, just to see if we already have access or not. No, we don't. Okay, then we're going to use Remediation again to do to inject that ticket like that, and then we're going to try and list out the directory on the domain controller again, and boom, we are now a domain admin using that ticket we snatched when the admin logged into our server. So that's how you use unconstrained delegation to escalate privileges. So after watching this video, you might be thinking that you want to try to get rid of all the unconstrained and constrained delegated systems. Well, in some cases that might not be possible at all. Some systems actually need this to work. So this all depends on your environment. What I would recommend though is try to go from unconstrained to either constrained or resource-based delegation instead, to make the setup a little more secure. I would also add an additional monitoring to unconstrained and constrained delegated systems, since they are critical in terms of the environment.